Hey, good morning, all my pre-calculus people out there. This is Mr. Ainsworth. When you get into your homework here on law signs and area of non-right triangles here. So let's just recall the last law signs briefly here. Okay, so we know that if a triangle has three angles, and they're called angles A, B, and C, capitalized that is, with lowercase sides, A, B, and C, where A is opposite of angle A, and B is opposite of angle B, and C is opposite of angle B, the law of sines is as follows, okay? It states that the sine of angle A to its opposite side is equivalent to the sine of angle B to its opposite side, and that's equivalent to the sine of angle C to its opposite side, C. Remember, this side is opposite of that angle. So that's an important note of how to use the law of sines. It applies to any triangle, but typically people use this on non-right triangles. When it's a right triangle, you just simply use basic, simple right triangle trig. SOHCAHTOA, that is. Okay, so let's label the sides here. So opposite of angle B, opposite of 109 is, okay, little b, and opposite of 37 degrees, well, that's little c, and so on. And we already know side A, that's 26 feet. All right, so it'd be kind of nice to know what the third angle is. And so let's find that third angle because opposite of 26 feet is angle A, and I need to know angle A to use size 26. So I know that all three angles add up to 180 degrees. So what I'm going to do is find angle A first. Okay, and so I know that 109 degrees plus 37 degrees is 146 degrees, and then 180 minus that. All right, will give me the angle A. So this is a measure of angle A here. So 180 minus 146, that happens to be 34 degrees. So this angle here is 34 degrees. Just using basic facts on triangles, we know that the sum of all three angles in any triangle always adds up to 180. You guys already know that because you are pre-calc students. Okay, now that we know that, then we know the following is true. So here we go. Let's go for it. So I'm going to take the sine of 34 degrees to its opposite side. So sine of 34 degrees to opposite side, 26. And that's going to be equal to the sine of 37 degrees to C. So the sine of 37 degrees to C. Okay, I'm going to cross multiply here. I get C times the sine of 34 degrees, all right, is equal to 26 times the sine of 37. Just cross multiply. Whenever you have proportions, the easiest way to handle it is simply cross multiply and then divide by whatever you need to solve for the unknown, which happens to be C in this case. So I'm just going to divide both sides by sine of 34 degrees, enter it in the calculator, and see what I get. And then round it to the nearest tenth, because the direction said round it to the nearest tenth. Okay, so what do we have? So 26 sine 37, let's use Desmos. So 26 times the sine of 37, I think that's what it was. And then we divide it by the sine of something. Forgot what it was. So divided by the sine of 34. So type in 34 right here, then approximate it. And you approximate around that to the nearest tenth, round up. That's about 28 feet. Okay, so 28 feet. Now we got to find side B, which is opposite of 109 degrees. Okay, so we take the sine of 109 now to its opposite side, and that's equivalent to the sine of 34 to 26. Sine of 34 to 26. We get to use that ratio twice. Okay, these are all in degrees, by the way. So you cross multiply and you get B times the sine of 34 degrees is equal to 26 times the sine of 109. Divide by the sine of 34 and you're done. All right, and B is equal to something here. So 26 sine 109. So 26 times the sine of 109. And then divide that by the sine of 34. So type in 34 degrees, round it, and it's about 44 feet. And when you round it to the nearest tenth, 0.96, you got to round up to 44. So you get about 44 feet here. Okay, that's all it takes. You just need to know the angle and its opposite side. Okay, so these two angles here, let me see, 21, So 21 degrees plus 75 degrees, that's equal to 96 degrees. And then 180 minus 96 sounds like 84 degrees here. So this angle is 84 degrees. So opposite of angle B is lower B, and then opposite of angle A is side A. So we got to find side A and B. Okay, we already know side C because that's 13. So we got to find these two sides. Okay, so let's go for it. So the sine of 75 to A, so sine of 75 to A, and that equals the sine of 84, excuse me, the sine of 21 degrees to 13, sine of 21 degrees to 13. Now, let me just tell you something. You're in pre-calc, so hopefully you get this here. Whenever you deal with proportions here, you always cross multiply here, so it's going to be 13 sine 75, and you're always going to divide by the fourth one here. So experienced people just write out the answer. A is equal to 13 times the sine of 75 degrees divided by the sine of 21 degrees, and they approximate it right there. You just go from proportion to answer and then use your calculator. So let's calculate it. So 13 sine 75 divided by the sine of something, 21 degrees, and then approximate it and round it, and that's about 35. So 35 centimeters there. So A is 35 centimeters. Now I got to find the other one. So I'm going to use the same ratio here, sine of 21 to 13, sine of 21 degrees to 13, because we know that ratio. Always angle to the opposite side. And I got to find sine of B, or B, so I got to use 84 degrees. So that's equivalent to the sine of 84 degrees to its opposite side, B. And then one more time, you just cross multiply these two, and then divide by the third term, always. So B is equal to 13 times the sine of 84 degrees divided by the sine of 21 degrees, and then you round it. So 13 sine 84, so 13 times the sine of 84 degrees, and then you got to divide that by the sine of something, 21 in this case, and then round it. That's about 36.1. Okay, so 36.1 in this case centimeters. Because again, nearest tenth, right? All right, and that is how you use the law of sines, okay? And then number 3 and 4. So I guess I'll do another one. All right, let me see. So opposite of this angle is B. And then opposite of 32 is 18 here, and we don't know this third angle, so we need to find the angle first. So 18 plus 32, that sounds like 150 to me. 180 minus 150 is 30. So this angle up here is 30 degrees. So here we go. So the sine of 30 degrees to angle or side C here, I'll find C first, is the equivalent to the sine of angle A, which is 32 degrees, all right, to its opposite side, 18. So you cross multiply here and divide by the third term. So C is approximately equal to 18 times the sine of 30 degrees divided by the third term, sine of 32 degrees. So 18 sine 30. So 18 sine 30. And then divided by the sine of 32 degrees. And that's about 17. So 17 miles in this case. So these are all in miles. So 17 miles, that's C. Okay, next one, let's find B. So the sine of 118, all right, to B is equivalent to the sine of 32 to 18. Sine of 32 degrees to 18. One more time, here we go. On proportions, you always cross multiply and divide by the third term. It always works out that way. So B is equal to 18 times the sine of 118 divided by the sine of 32. And then when you work that out, 18 times 118. So 18 times the sine of 118 divided by the sine of 32 degrees. That's about 30. So 30 miles. So this is 30 miles. Okay. Okay. And you guys can do the fourth. And these are review problems right here. This is section 9.2. Okay, review. And so this is a side angle side case. Find the area on a side angle side case. And remember from the previous lesson here, this is the area of any triangle is 1/2 times side, side 1 times side 2. Okay, let me rewrite that. Okay, so 1/2 times side 1 times side 2, S2. Let me write it better here. Side 1 times side 2 times the sine of the included angle. So angle A, let's call it in general. Okay, that's the included angle. Okay, so the sides have to be adjacent and the angle has to be between the two given sides. All right, so let's go for it. So the angle or the area here would be 1/2 times 8.7 inches times 15 inches times the sine of 54 degrees. So what would that area be? So let's figure it out. Okay, here we go. So enter in 1/2 or 0.5, all right, times 8.7 times the other side, 15, times the sine of the angle between them, which is 54, and you round it to the nearest tenth, and you get about 52.8. So 52.8 square inches, okay? Remember that an inch times an inch gives you a square inch. Always square units, okay? And the last one here, 1/2 times 15.9 yards times 14 yards times the sine of the included angle, which happens to be 96 degrees. It's not a right triangle. And the area is, let's figure it out. So it's 0.5 times 15.9 times 14, all right, times the sine of the angle between them, which is 96 degrees, and you approximate it to about 110.7. So 110.7, and again, a yard times a yard is a square yard, okay? So square units. And that's how it's done. Okay, so again, this is just the law of sines, which we need for non-right triangles. Notice that none of these triangles were right triangles, so you couldn't just use basic SOHCAHTOA right triangle trig. All right, you have to use what's called the law of sines. All right, next is the law of cosines in section 4. I'll see you then. Bye-bye.